Section 16.3, the autoionization of water. If you remember that water is amphoteric or amphiprotic, both of this means that they can act as acids or they can act as bases. Well, if you can act as an acid and you can act as a base, in some situations, water in a glass of water with other water, some of the molecules can act as acids and give away protons, and some of the other water molecules can act as bases and receive those protons. So every once in a while, okay, so here you have a couple of water molecules. There's two water molecules. The one can transfer to the other, okay? So now you're going to have one that's just hydroxide, which is a base, and one that is a hydronium, which is an acid. So you've got just exactly the same amount of acid and bases, okay? Same amount. In a normal glass of water, okay, in a normal glass of water, you're going to have a certain amount of hydroniums and a certain amount of hydroxides. It happens, this is by measurement, someone's experimented and done a measurement. They found that the concentration of H3O plus is going to equal 1 times 10 to the minus 7 molarity. And the same, since they're 1 and 1, you're going to have the same thing here. So the concentration of hydroxide is also going to equal the same, 1.0 times 10 to the minus 7 molar. Now that is pretty cool because water is so useful. It's everywhere. It's everywhere in the world in terms of chemistry. So this is one that you actually should know. Now, if you remember, we've learned equilibrium constants. K sub C, okay, equilibrium constant, is you look at your balanced equation, you go to the products, and you take the concentration of hydronium times the concentration of hydroxide divided by the concentration of water, and then there's a red flag that goes off in my head and go, wait, I can't divide by water because that is a pure liquid. Remember, pure solids and pure liquids, anything that's a solid or liquid, we simply ignore it. So it's not going to be in the equilibrium constant. So K sub C is going to be the concentration of hydronium times the concentration of hydroxide. It is so useful that we gave it its own letter, okay? Because you don't have enough of these K's to memorize. K sub W is simply the equilibrium constant of water. And it's going to be called the ion product constant. It's just the equilibrium constant, nothing else. The equilibrium constant of water. But because this experiment, someone's already done the experiment, and water's water, and you know that it's 1 times 10 to the negative 7 for hydroxide, 1 times 10 to the negative 7 for hydronium, then when you stick those numbers in, okay, both of these numbers in here, you are going to get the K sub C of water, which is we call K sub W. The K sub W of water is 1 times 10 to the negative 14. Now that's something you need to memorize. But you really don't even have to try, because as you use this, you're going to realize that 14 is going to be the end of the pH scale. The pH, which talks about how acidic or how basic something is, goes from 1 to 14. And the reason it goes from 1 to 14 is that it's a logarithm, which means we're just looking at just the negative exponent here. So instead of something to the negative 14, it's just a 14. And the scale goes from 1 to 14. And if it's completely 14, we're going to talk about that being basic. If it's very, very low, like a 0 or 1, we're going to call that very acidic. So just knowing that the total is 1 times 10 to the negative 14 means that if you know the concentration for one, you can find the concentration for the other because you just plug it in to K sub W. K sub W is going to be one you know all the time. Okay, so if you know that K sub W is equal to the concentration of hydronium times the concentration of hydroxide, then you solve for which one you don't know. If you know one and don't know the other, solve for it. Case of W is one that you think of as a constant. You just know this. It's always going to be 1 times 10 to the negative 14 is the equilibrium constant of water. And since you're going to use it all the time, you can find one that you don't know based on one you do know. So from this, we get some really obvious stuff, things that you can basically guess. You know that if you've got more base than acid, okay, so if the concentration, remember case of W is a concentration of hydronium times the concentration of hydroxide, and that equals 1 times 10 to the negative 14, then you know that as this one goes up, this one will go down. Okay, so if you've got lots and lots of hydronium, you're going to have a little bit of hydroxide, and we're going to call that acid. The high pH was where we're going next. pH is P hydronium, the amount of hydronium in something. So if you've got high amounts of hydronium, then you're going to have lower amounts of hydroxide. If you have them canceled out, which is going to be 1 times 10 to the 7, 1 times 10 to the 7, well, that's a 7, neutral. Okay, a pH of 7 would be like water. Water has a pH of 7 because when it breaks apart into hydroxides and hydroniums, it's a 1-to-1 relationship. They cancel each other out, and it's neutral. If you have lots of hydroniums and very little hydroxides, then you're going to have acids. If you have lots of hydroxides and very little hydroniums, you're going to have bases. So, acidic is higher concentrations of hydronium than hydroxide. Neutral is equal amounts of hydronium and hydroxide. And basic is lower amounts of hydronium, higher amounts of hydroxide.